All right, so let's start. Let's start by remembering what we mean when we say congruent. What are we talking about when we're talking about things being congruent? Same size, same shape. That was kind of our everyday definition. So what we're going to do today is start making our definition a little more technical, and so that we can actually do some things to actually figure out when shapes are congruent. Come up with some rules about when shapes are congruent. And we use congruent shapes to solve all kinds of problems in geometry. We also use congruent shapes dealing with figuring out when things are the same size and shape in all kinds of different areas. In science, we use the idea of congruent shapes a lot. Architecture, construction. So figuring out when shapes are the same size and that when you can compare them in a certain way is kind of an important thing. All right, so the first thing we're going to talk about, the first shape, is a polygon. So let's just remember what we mean when we're talking about a polygon. We came up with an idea, it was a while back, idea about what a polygon was. So who can help us out about what we mean when we talk about a polygon? What does the roots, what does this prefix poly mean? Many. And gon, actually, so polygon means it's a shape with many sides. The word gon, the piece gon actually comes from angle. So it has a lot of sides, but it also has a lot of angles. So many sides. And we also said there was something else that had to happen, several other things that had to happen in order for us to have a polygon. What is it? Straight sides. The sides are straight. The sides are segments. So we can say straight sides. So a shape with curved sides is in a polygon. And there was something else that was important about a polygon. So here's something with many sides. Is that a polygon? No, it has to be closed. There we go. So it has a lot of sides, it has straight sides, and it's closed. So thinking of that, what's the least number of sides a polygon could have? 3. So if we have less than 3 sides, all we have is an angle, right? We can't make that closed unless we put the 2 pieces right on top of each other. So 3 sides is our smallest polygon, and 3 sides makes a triangle. So that's why we deal with triangles a lot. So just really quickly, how we name polygons. And we've referred to polygons, we've written polygons, but just so we're clear on how we talk about them. If I have some polygon, some shape, we usually name the vertex with letters. And we could call this polygon, we can start on any vertex, and we go around in order. Start on any vertex and go around in order either direction. So we're going to start on a vertex, go around in order. So we could call this polygon A, B, C, D, E, F, G. We could call it A, G, F, E, D, C, B. We just have to go in order. And we can start on any vertex. So it doesn't matter which vertex we start on. But the letters always go in the order that they are on the polygon. So we don't skip around at random. We go in order either clockwise or counterclockwise. And that order is going to be important when we start comparing two polygons. So what we're interested is we'll talk about what happens with one polygon, but a big part of what we do in geometry is compare two shapes. So how we name them has to do with how we compare them. So these are the ideas that we're going to start with. There's another important piece of vocabulary that we're going to talk about, and that's the idea of corresponding. We're going to use the word corresponding when we talk about congruent polygons a lot. So let's figure out what corresponding means. In everyday language, what do we mean when we're talking about something being corresponding? Anybody have an idea? And not correspondence like writing back and forth, but if we say that some action corresponds to something else, or this, what's that? It matches up, right? It's matching. That's exactly what corresponding means. Corresponding just means matching. So we'll talk about corresponding sides and corresponding angles in polygons. So the corresponding sides means that we're matching things that are the same. And then we'll also talk about corresponding angles. And when we say match, we're not necessarily saying that they're the same size yet. We kind of mean they're in the same place. The corresponding angles are angles that match.
What do you mean by that?
So if I had, that's a good question. If I had a triangle that looked like this, and then a bigger triangle that looked like this. So you'd say the shorter side corresponds to the shorter side, the medium side corresponds to the medium side, the long side corresponds to the long side. So they're kind of in the same place is a way to think of corresponding. And same with the angles. The big angle corresponds with the big angle, the medium angle corresponds with the medium angle, and the small angle corresponds with the small angle. So that's what we're talking about when we say corresponding. Corresponding is going to be an important idea. So if it helps you remember it, you can say big to big, medium to medium, small to small, etc. So we're just matching up those parts. So we're going to say, so we're going to use this idea of corresponding to define when polygons are congruent. We want to know when they're congruent. We want to figure out when they're the same size and shape. So we're going to say our definition of congruent polygons. So this is our some books, some people say this is a postulate, some people say it's a definition. We're going to use it as a definition. Congruent polygons. So we're going to say polygons are congruent, two polygons are congruent. And we're going to say if and only if. And remember back in chapter 2, that's how we made our definitions. We said if we could write it as an if and only if, it was a good definition. So two polygons are congruent if and only if we have two things. Pairs of corresponding angles are congruent. And maybe I should say each pair So each pair of corresponding angles is congruent, and we have to have each pair of corresponding sides congruent. And that's how we tell if two polygons are congruent. We match up the corresponding sides, the big side to the big side, the small side to the small side, medium side to medium side, etc., depending on how many sides they have. And if each pair that we match up is congruent, then our polygon is congruent. So that's how we tell that they're the same size and the same shape. Match them up, and each piece has to be congruent. So let's look. I want to draw a couple of pictures, and we'll talk about how we make these corresponding, how we match up the sides and the angles, and then we'll talk about how we figure out if polygons. Just a couple of examples how we figure out polygons are congruent. Is everybody good with our vocabulary and how we said we decide that these are congruent? These polygons are congruent. All right, so let me draw a picture here. And we want to figure out how these polygons, we'll start out with triangles, how these polygons correspond. So we'll draw a triangle, a couple of triangles, and I'm going to mark them up. So I'm going to put this, let me call this triangle ABC, and this triangle XYZ. All right, so the question, our first question, so which side corresponds to segment BA? Which side is going to correspond to segment BA? Matt? Segment YZ. Because these two are marked as congruent, so that tells us that they're the same size. How about segment BC? Which segment is going to correspond to segment BC? What do you think, Ryan? Which segment is going to correspond to BC? Well, how many marks does this one have? Got 3 marks? So which other one has 3 marks? XY. Very nice. So that's going to correspond to XY, and then AC has to correspond to XZ. And then we could mark angles. We could match up our angles as well. So if I mark these up, I would say that. And we could do the same thing with our angles. So angle B would have to correspond to angle Y, angle C would have to correspond to angle X, and angle Z would have to correspond with angle A. Could we now say that these two triangles are congruent the way they're marked up? Each pair of corresponding sides is congruent, and each pair of corresponding angles is congruent. So we could say those two are congruent. So if we're going to write that they're congruent, I would say that triangle ABC is congruent to, and I need to write the other triangle in the order that it matches up with triangle ABC. So which angle corresponds to angle A? Z. And which angle corresponds to angle B? Y. And that leaves for angle C, X. So when we write that they're congruent, the order that we say that we list their vertices tells us how the parts match up. So angle A matches with angle Z, angle B matches with angle Y, and angle C matches with angle X. Side AB matches with side YZ. That's what we wrote here. Side BC matches with side YX. That's what we wrote here. And then finally side AC matches with side ZX. That's what we wrote there. So when we write that they're congruent, that also tells us how they match up. So we have to make sure we write them in the right order. We write them exactly the way they match up. So let's look at another one of these and figure out how we're going to write that these shapes are congruent. This time we won't work with a triangle. All right, questions on what we did here? So here are my shapes this time. And with all of these things, we've talked about this before, go by the way the picture is marked, not by the way it looks. And I'm going to call this A, B, C, and D. And E, F, G, and H. Now let me mark up some sides here. And I'll mark some angles as well. There we go. Now we have this all marked up. So I want to say that polygon ABCD is congruent first. Can we say that these two polygons are congruent? Can we match up each side with a congruent side on the other one, each angle with a congruent angle on the other one? We can match them all up. So we're going to write that they're congruent. So what angle matches with angle A? Angle E. How about with angle B? F, G, H. If I wrote these in a different order, if I wrote C, D, A, B, I would have to write these in a different order, and I'd have to write the order that they match up. So this would have to be G, H, E, F. So we make sure that the parts match up in the right order. So when we write the two things are congruent, we make sure that we match them up in the right order. So questions there? So for polygons to show that they're congruent, we have to be able to match up the sides and the angles and show that each pair is congruent. That's how we decide if polygons are congruent. Triangles are nice because we can come up with some shortcuts. So let's start by coming up with one of the shortcuts that we're going to use for triangles. Our book calls this the third angle theorem. It's not, the name of it isn't important, but it might help you remember. And it has to do with what we did on the opener. So let me draw two triangles. And we're going to say that this is triangle A, B, and C, and triangle D, E, and F. And we're going to say that those two angles, that angle A is congruent to angle D, and angle B is congruent to angle E. This should be 2. So if those two in those two triangles, if these two are congruent to these two, what can we figure out? Did you have a question, Ash? Good. If these two angles are congruent, what can we figure out about the third angle? So all three of these have to add up to 180, right? And all three of these have to add up to 180. So this plus whatever angle C is 180. These two are the same. So we have to have the same angle here in order for these three to add up to 180. So our theorem says that if this is true, then angle C is congruent to angle F. If two angles of a triangle are congruent to two angles of another triangle, the third angles have to be congruent. And that's kind of what we saw on the opener. If we know that these two add up to 180, or these two plus this third one adds up to 180, and these two are the same, then the third one has to be the same. So if we say this in words, if two angles of a triangle, I'm going to use some shorthand. Two angles of a triangle are congruent to two angles of another triangle, then the third angles are congruent. So this gives us a shortcut for figuring out some things about triangles. We know that two angles are congruent in a pair of triangles, then the third angle has to be congruent. So what I want to do next is go through a proof of how we would prove that two triangles are congruent by showing that all the corresponding angles and sides are congruent. And then we're going to talk about some shortcuts for triangles. We have some shortcuts for figuring out when triangles are congruent. So this third angle theorem can help us to shortcut some things with triangles. So let's look at this proof. So I'm going to draw a picture here. and we'll have some information that we know, and we want to show that these triangles are congruent. So this is S, T, U, and R. Those two pieces are congruent. Those are congruent. Those are congruent. And these are congruent. So we're going to start with our givens. Given angle S is congruent to angle U. I'm just writing down what we have here. Segment ST is congruent to segment TU. That's this piece. Segment SR congruent to segment UR. And then finally, say angle SRT is congruent to angle URT. I got my angle sign there. And with this information, we want to prove that triangle SRT is congruent to angle URT. So I'm going to do a two-column proof here. Our statements, and our reasons over here. I'm not going to rewrite all the given in our proof. We know that we're given all of this information. So looking at this piece at these two triangles, what do we need to know in order to show that all the corresponding sides and all the corresponding angles match up? What information are we missing here? So we have two sides and two angles. How many sides of a triangle do we have to match up to show that it's congruent to another triangle? We have to match up all three. And how many angles do we have to match up? 3. We have to match up all 3. Well, we have 2 angles and 2 sides, so we need to figure out how to match up the third angle and the third side. So let me write an angle here. Angle STR. I want to say that angle STR, we mark it in red. I want to say that those two angles are congruent. So angle STR is congruent to angle UTR. How could I say that those two are congruent? We know that these two are congruent to these two. Isn't that the theorem we just talked about? If two angles of one triangle are congruent to two angles of another triangle, then the third angle has to be congruent. So we can say that those two are congruent by the third angle theorem. And I can just say third angle. So now we have 3 angles, we need 3 sides. Well, now they share this side TR. So I'm going to say segment TR is congruent to segment TR. Who remembers what our reason is that we can say something is congruent to itself? What is it? Symmetric, that means we can turn it around, so you're very close. Think of the word we confuse it with was we thought of it being the same on each side. So a lot of us wanted to say reflective, but this would be the reflexive property. When something's congruent to itself, it's the reflexive property. So now I've said that this third side is congruent. So now I can say triangle SRT is congruent to triangle URT, and we can say that this is by the definition of congruent polygons. So we showed that all three sides are congruent, all three pairs of matching sides are congruent, and all three pairs of matching angles are congruent. So questions on that? All right, so with polygons it takes a lot of work to show that they're congruent. We have to match up each side. With triangles we have a couple of shortcuts. So let's talk about the shortcuts. The shortcuts are what are on your graphic organizer. So we're going to fill out a couple of parts of your graphic organizer next. So this is what we're talking about now is shortcuts for triangles. And we're going to talk about two shortcuts. So for polygons we have to make sure all the sides and angles match up. For triangles we have shortcuts, kind of like what we talked about with the third angle. We know the two angles in one are congruent to two angles in the other. The third angle has to be congruent. All of our shortcuts have to do with those kinds of ideas. So the first one is on your graphic organizer up in the upper left. It says SSS. SSS stands for side, side, side. And our side, side, side postulate, all of these are postulates, is that if the sides of one triangle are congruent to the sides of another triangle, then the two triangles are congruent. Good break. So if all the sides of one triangle are congruent to all sides of another, then the triangles are congruent. And if you want to mark the drawing on your graphic organizer, your drawing looks kind of like this, and you would mark your sides like that. So the sides, all the sides of one triangle are congruent to all the sides of the other triangle. So that's one shortcut for triangles, is if we can show that all the sides are congruent, we don't need to worry about the angles. All the sides being congruent guarantee that our angles are congruent. And then the next shortcut is down below that one. The next shortcut is SAS. And that is side, angle side. And side angle side, there's a little twist to it. It says if two sides and the angle between them are congruent to two sides and the angle between them on another triangle, then the triangles are congruent. I'm going to say they are congruent. We call the angle between the included angle. So our picture on our shape, on our graphic organizer, sorry, looks something like this. So we're talking about two sides and the angle between them. So I'm going to mark, let me go back. Like so. So we have two sides and the angle that's between those two sides. So our angle has to be between our two sides. That's what we mean by included angle, or between, the angle between. So it has to go in the order side, angle, side. I can't just pick any two sides and any angle. It has to go in this order side, angle, side. Side, angle, side. They have to match up exactly. If that's true on two triangles, the side, the angle, and the side match up, then we're guaranteed that the other pieces match up, and that's all we have to do to show that those two triangles are congruent. Once we know that that's the case, then we're done. That's all we need to do to show that those two triangles are congruent, to show that we have a side, angle, side congruent on both. All right, so what I want to do next is draw some pictures, and we want to decide, are the triangles congruent? Are they not congruent, or can we not tell? If we do we not have enough information? All right. So here's our picture. And then we want to say congruent, not congruent, or can't tell. And if they are congruent, we want to say why. Are these congruent? Yes. And why? Two of the same sides, and, whoops, this should be, there we go. So what do we call this combination? Side, angle, side. Yes, we would say by side, angle, side. That's all we would have to do to say that those two triangles are congruent. Those are congruent by side, angle, side. Let's look at another example. Draw some more triangles. How about these two? Got some heads nodding. So go by what the diagram says, not by what it looks like. Go by how they're marked, not by how they look. So are these congruent? Yes? And what would be our reason? Side, side, side. So we'd say yes by side, side, side. Those are congruent. How about two more? How about these two? Manny says no. Evan says no. Ashley says no. Are they not congruent, or do we not have enough information? Don't have enough information. What's the problem here? We have two sides and an angle. Isn't that side angle side? No? Why isn't it side angle side? The angle is not between them. The angle is not between the two sides. In order to have side angle side, my angle would need to be here and here. This one is in between. So the angle isn't included, so this one is not enough information. We'd have to know something about another angle or another side to figure out if these two are congruent. Let's look at another one. Are these two triangles congruent? Rayanne says yes. Someone says not enough information. Anyone else? Evan says yes. What do we know about this side for the two triangles? It's congruent to itself, right? So we could mark this like so, and then we would say yes by, what's our reason? Side, side, side. We have three sides. One last one, and then we'll look at a different kind of example. Here are my triangles for this one. So there are my two triangles. Congruent, not congruent, or not enough information. Sam says not enough information. We only know about one pair of angles and one pair of sides. So this is not enough info. We need to figure out some more stuff about these two triangles to decide if they're congruent. All right, last question, a little bit different kind of question. Let me draw a picture. And we want to figure out what else we need to know. It's kind of like the proof that we did. What else would we need to know that these two triangles are congruent by side angle side? So, what other info do we need? For side angle side. Well, let's start out by figuring out what we do know. What do we know? What do the little squares tell us? Those are right angles. So what do we know about these two angles here? They add up to 180, and how do they compare? They're congruent. So we know one set of congruent angles. So if we wanted to, we could put our congruent marks on the little squares. So there's our angle for side angle side. Do we know any congruent sides here of the two triangles? Right? AC is congruent to itself. So there's a side, there's an angle. So what else do we need to know? And let me back up and make those in red, because we figured that out. I'll put what we figured out in red. So we figured that out, we figured this out. So what else do we need to know to decide these are congruent by side angle side? this angle needs to be between the sides. So what side do we need to know on this triangle? BC, right? So we need BC, and which side is it going to compare with on this triangle? CD. We need to know something about BC and CD to decide if these two are congruent about side angle side. If we knew that they were congruent, we knew this was congruent to this, I'll mark that in blue, and I'm going to say question mark. If those two were congruent, then the two triangles would be congruent by side angle side. So we know that the angles are congruent because they're both 90 degrees. This side is congruent to itself. So if we knew that BC is congruent to CD, then we would be able to figure out that the triangles were congruent by side angle side. So questions on that? All right, let's summarize a little bit. Polygons. Polygons, for polygons to be congruent. And that's any multi-sided shape closed with straight sides. For polygons to be congruent, we have to match up pairs of sides and pairs of angles. So all pairs of sides and angles have to be congruent for them to be congruent. We can always do that with triangles also. We can match up all the pairs of congruent sides and angles. For triangles, we learned a couple of shortcuts, and we'll learn a few more over the course of the chapter. We can use side, 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 and so far we've learned side, angle, side. We can match up a side, side, and side, or we can match up a side and angle and a side to show that they're congruent. So that's our big picture for this lesson. For polygons, match up all sides, all angles. For triangles, so far we know about side, 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 and side, angle, side. All right. Stop this.